Welcome to Secure, Deliver, and Optimize your modern generative AI apps with F5. Today, I will demonstrate how F5 can enhance and elevate your generative AI strategy through robust security, efficient delivery, and optimization solution. Here is a snapshot of the demo setup for today. In my demo, I will cover Enterprise Retrieval Augmented Generations, or RAG for short. F5 role in securing and optimizing these RAG-enabled AI applications and practical implementation of this chatbot. According to F5 2024 State of AI Application Strategy reports and Forbes Advisor survey, AI is playing a significant role in enhancing customer experiences. 73 to 75% of business currently use or plan to use AI assistant or AI-powered chatbot for instant messaging. This statistics highlights the growing importance of AI in customer interactions. Among various AI applications, chatbots stand out as a particularly valuable tool. They serve as a foundational element for businesses to engage and support their customer effectively. Imagine your organizations having a chatbot that understands your customer needs, possesses historical knowledge about their buying patterns, preferences, likes, and dislikes. Such a chatbot can foster a highly personalized and intimate relationship with customer. Indeed, AI-powered chatbot is one of the top business drivers of AI adoptions. Throughout these demonstrations, I will explore how F5 solutions can help you implement, secure, and optimize your chatbot and other AI applications, ensuring they perform at their best while protecting sensitive data. After the demonstrations, I will discuss how you can start implementing these solutions in your own organizations. Are you ready to transform your customer interactions with AI-powered chatbot? Intelligent chatbots are powered by AI, which in turn is fueled by data. The quality of this data is paramount to the success of any AI strategy. Just as blood is essential for life, high-quality data is the lifeblood of AI. Without it, an AI strategy may fail, adhering to the principle of garbage in, garbage out. The accuracy of an AI chatbot's responses directly correlate with the quality of data it has been trained on. AI-powered chatbots typically leverage large language model or LLM, which are pre-trained on massive amount of text to interpret, predict, and generate human-like responses. However, these models are often trained on generic dataset, which can limit their effectiveness in specific corporate contexts. Training a corporate-specific LLM or fine-tuning an existing one with proprietary data can be expensive. This is where RAGs comes in. RAGs addresses these challenges by incorporating domain and organization-specific knowledge into the LLM workflow. At its core, RAGs enhance LLM by retrieving relevant information from a provided database as context before generating text. Let's walk through how the RAGs frameworks works. Typically, RAGs involve two key workflows. First, on data preparations and embeddings, where enterprise data is broken into manageable chunks. These chunks are fed into the LLM to generate vectors arrays called embeddings. The text chunks and their corresponding vectors are stored in a vector database. This database is later used for searching during the question and answer phase. Then on question and answer phase, a user question is input into the same LLM to generate a vector embedding of the query. This embedding acts as a query key to search the vector database. The system finds vectors in the database that are closest or similar to the query vector. Text chunks corresponding to these closest vectors are retrieved as relevant information. These relevant chunks are included in the input to the LLM to generate a contextual, appropriate responses to the user. In this demo setup, I will leverage LangChain framework, which acts as an orchestrator for the LLM ecosystem, managing interactions between related components. LLM, model, LangChain framework, vector database, and AI chatbot are all deployed on F5 Distributed Cloud App Stack, bare metal, supported by NVIDIA A2 and NVIDIA T4 GPU for optimum performance. In addition to F5 App Stack, I have F5 Nginx Plus serve as an API gateway to the LLM, providing enhanced security and protections. VectorDB, containing sensitive corporate data, resides in the data center for data residency and compliance. It is protected by F5 Distributed Cloud Services. The inference engine is deployed at the edge or can be distributed into multiple edges and connected to the data center via F5 Distributed Cloud Encrypted Mesh Fabric. This fabric creates a secure encrypted overlay network, facilitating apps-to-apps communications between all AI components. Here is the F5 Distributed Cloud console, where I have two App Stack site registers, Metal A2 and Metal T4. Here is where I created all my HTTP LB, where all these LB facilitate the app-to-apps communications. I'm using Flowwise, an open source low-code LLM app builder, where I leverages LangChain to orchestrate the language model with other AI components. I'm using Ollama, an open source project for running a private LLM on AppStack. I had Ollama Web UI and its correspondence private LLM model installed both on Aegis as well as on DC. I'm using Milvus as my private vector database running and protected by F5 Distributed Cloud. Here is how the chat flow looks like. I have Cheerio Web Scraper scraping the main website. For these demonstrations, I only scrap information related to organization's team. You can also load content such as PDF or text file into the Milvus database. Prior storing into vector database, corresponding text chunks will be converted into vector array via an Ollama embedding chain. This demo, I'm using Llama 3 as my language model. Conversational retrieval QA chain will search and retrieve relevant data from vector store and send to Ollama chat for response generation. Here is the corporate website that LangChain framework extract information from. Currently, RAG-enabled AI-powered chatbot is integrated into this Acadia trading application. Let's do a side-by-side comparison of the outcome of a RAG-enabled chatbot versus without RAG. On my left is a RAG-enabled chatbot, and on my right, I'm using Open Web UI that interacts directly with the LLM. For this demo, I only extract information related to Board of Directors. Acadia Finance chatbot will have context information related to Board of Directors. Now let's log in and interact with the chatbot. Let's start with a generic greetings to the chatbot. How are you? I'm going to do the same for the Open Web UI. I'm using Llama 3 as my language model. As you can see, both responses with a generic answer on my greeting. Now, let's ask a more specific question. I am interested to invest. Tell me who is the chairman of the board. I'm going to copy the same question and put it into the Open Web UI. From this response, you can experience that for Acadia chatbot, it responses that Tony Smart is the chairman of the board of Acadia Financial and a member of the company's board of directors and so on. Where for Open Web UI, which is a generic LLM, it doesn't know and requested for more context from you. Let's try another different questions. Great. Could you please give me more details about him? I will do the same for Open Web UI. For Acadia chatbot, it provides more details information about him. Him, in this case, about chairman of the board, which is Tony Smart. Acadia chatbot understood and remember my first questions about chairman of the board, where for Open Web UI, is trying to clarify that he is an LLM and don't have access to real-time information. It basically has no organization context regarding the question I asked. It's frustrating interacting with Open Web UI with no context information about the question I'm asking because it is a pre-trained on generic dataset from internet. Let's try more questions. How about the treasurer? Acadia chatbot responses that Chris Wong is the treasurer of Acadia and executive president and CFO. Again, it has organization context information. Similarly, Open Web UI do not have any context information of the organization and unable to give me a satisfactory answer. Imagine you have an AI chatbot with context information versus a chatbot that don't have context information. A chatbot that understand and have context information will foster a closer relationship with the customers. Let's conclude this question and answer with a kind words to the both chatbot. API is crucial for AI. It facilitates communications between AI services. It's foundational for a successful AI strategy. Hence, API strategy is crucial for an AI strategy. This includes secure, deliver, and optimize your API to support your AI strategy. Here is a quick snapshot of how F5 platform discover those API that runs within the AI application. Fundamentally, visibility is one of the key attributes for security. You can't protect unless you can see. API discovery is important for API security. Once API discovered, you can start to implement control to monitor and secure those AI components. You can apply rate limit, malicious user detections, API protections, and attack detections mechanism. In this demo, you have experienced how F5 secure, deliver, and optimize your modern GenAI applications with Enterprise Retrieval Augmented Generations framework. Feel free to reach out for further details and deep dive sessions. Thank you.